All right, let's take a look at this example over here. So as you can see, this is question number 12 from homework section 10.2, and the problem number is 10.2.28-T. Now that T honestly stands for technology. So the idea is you can use technology to do your computations here. So let's take a look at this. The problem says previously 4% of mothers smoked more than 21 cigarettes during their pregnancy. An obstetrician believes that the percentage of mothers who smoke 21 cigarettes or more is less than 4% today. She randomly selects 125 pregnant mothers and finds that 2 of them smoked 21 or more cigarettes during pregnancy. Test the researcher's statement at the alpha equals 0.05 level of significance. So obviously you can see the first part of the question is what are the null and alternative hypotheses? So of course the null hypotheses would be what they're telling us about the previous data or survey results. So they're saying 4% of the mothers smoked 21, more than 21 cigarettes during their pregnancy. So that's of course a probability. So that's P, and the probability equals 4% as a decimal would be 0.04. Okay. Now they are saying that in today's time, an obstetrician believes that the pregnant mothers are smoking less than, pregnant mothers who smoke 21 cigarettes or more is less than 4% today. So that's going to be our alternative hypothesis. So again, that's a probability, which we are saying today, or actually the doctor is saying should be less than 0.04, which is of course 4%. So let's go ahead, check that answer, and that looks good. Now we need to see if we can use normal distribution, or would we have to use, binomial distribution, since this may not be a normal distribution kind of problem. So let's take a look at this calculation here. So you can see we need to multiply n times p sub 0 times 1 minus p sub 0. So of course your n is going to be the sample size. So in this case, we can see we're talking about selecting randomly 125 pregnant mothers. So that's our n value. P sub 0, of course, is going to be the initial probability we started out with, which is 4%. And then, of course, 1 minus 4% will be 96%, right? So let's go ahead and multiply those and see what that answer comes out to be. All righty, let me pull up my calculator here. All righty, so let's take a look here. So our n value is 125. We're going to multiply that with our initial probability of 4%. So that's 0.04 times, we are going to multiply with that 1 minus 4%. So remember that was 96%. So 0.96, and let's see, that comes out to be 4.8. So let's plug that in here. 4.8, of course, is a number smaller than 10. So it's got to be a number equal to or greater than 10 if we can use the normal probability model. So since we did not get a number equal to or greater than 10, we cannot use the normal model to approximate our p-value. So let's check that. And then the next question was, of course, finding the p-value. So let's take a look at how we can do that calculation. Okay, so what I would recommend for this one is to go under StatCrunch and use that to do your calculations. So you can see in your problem, you can just go under Get More Help and you can click on StatCrunch, but I've already opened it for us. So let's go ahead and take a look at this. So you will actually be going under the Stat menu option, go under calculators and click on binomial, because remember, as I said, since we cannot use normal, we will be using the binomial distribution. So I'm going to click on binomial, and looks like I've got some previous numbers in there, or actually I think it floods it automatically when you click on that. So just going to plug in our number. So remember, our n value is 125 pregnant mothers. Our probability is at 4%. So again, remember that's a decimal of 0.04. And then in the example, or in the problem, they're telling us the obstetrician randomly selects 125 pregnant mothers and finds that 2 of them smoked 21 or more cigarettes during pregnancy. So this number here needs to be 2. Now you will notice that we are using the less than equal to symbol here when we're calculating our probability for the binomial distribution. And that, of course, is because we are trying to figure out if, there are less than 4% women smoking, during pregnancy today. And the other thing you will notice is when we take 2 out of 125, you will see that is a percentage much smaller than 4%, which was given to us, right? Because you can see this is coming out to be what, 1.6%. And so that's the reason why we are using the less than equal to symbol over here. So making sure we got all our numbers in there, and then we go ahead and hit compute. And of course, you can see this is a left-tailed binomial distribution, right? So our probability p-value is coming out to be, looks like 0.11955, and they want us to round to 3 decimal places. So this will become 0.120. 0.120. All right, let's check that guy. And he looks good. So remember, the idea is when you are comparing the values, you need to see in comparison with the level of significance, the alpha value, what is our p-value looking like. And of course, in this case, a p-value of 0.120, which comes out to be 12%, is definitely larger than the 0.05 level of significance, which again is 5%. So the idea is you have to decide, do we reject or not reject the null hypotheses? And in this case, we will be rejecting the null hypotheses. And you can see there are 2 options over here. Yes, reject the null hypotheses because p-value is less than alpha, or reject the null hypotheses because the p-value is, oh, sorry, I'm reading that wrong, aren't I? Sorry, our p-value is greater than the null hypothesis, so we actually do not reject our null hypotheses here. Okay, so I think I did say that incorrectly. If your p-value is less than alpha, that is when we reject the null hypotheses. But in this case, you can see our p-value is greater than alpha, the level of significance. Of course, we cannot reject the null hypothesis. So we will be saying, do not reject the null hypotheses. And then you have to choose between the 2 options here, C and D. So do we not reject the null hypotheses because there is sufficient evidence to conclude the percentage of mothers who smoke, 21 or more cigarettes is less than 4%? Or do we say, do not reject the null hypotheses because there is not enough evidence? And I would go with there is not enough or sufficient evidence to, make a claim that less than 4% of pregnant mothers are, smoking 21 or more cigarettes. So that would be the option I would choose. So I hope this helps you out just to see, how to go about using technology, in this case, specifically StatCrunch, to come up with this p-value calculation. All right, guys, let me know if you have any other questions about homework. Take care, everyone. Good luck.